Okay guys, there's a stack of questions here on subtraction. Each have a slightly different skill set. So I'm going to start at possibly the most easiest entry place, which is the 2003 HSC question. It says using 4-bit binary and 2's complement, perform the following subtraction. Now what's going on and why do we have to use 2's complement? Well, in the introduction video, we learnt that, the ALU doesn't actually know how to subtract. It actually only knows how to add. So what can I do to how can I manipulate a subtraction arithmetic to actually turn it into addition? You might remember from year 8, year 9 and year 10 maths, a negative plus a positive equals a negative. Okay? To find the 2's complement of the number, finds its negative equivalent, so you'll actually be able to find the negative equivalent. So then you'll actually be able to go 1, 1, 1, 0 plus negative this number, and a negative and a positive equals a negative. So you'll actually be performing addition. If that confuses you a little bit, you're more than welcome to just remember the process. If you ever get a subtraction, you find the 2's complement of the second number, and you use that to be able to perform the addition. Okay, so what's the 2's complement? You remember from the previous dot point that 1's complement, you just invert the numbers. So the 1's complement of this number would be 1, 0, 0, 0. 2's complement, because there's only one number for negative 0, is 1, 0, 0, 0 plus 1. Okay, so let's do a couple of these so we get the hang of it. Okay, so if I go in here, I've got 1, 1, 1, 0 minus 0, 1, 1, 1. I know the ALU can't do subtraction, so I actually have to turn this into its negative, so that negative number, and then perform an addition. Okay, so 0, 1, 1, 1, that is the number. To find its 1's complement, I invert the numbers. 1, 0, 0, 0. So that's the 1's complement of that number. Now to find the 2's complement of that number, I simply add 1. There you go. So I've got 1, 0, 0, 1. Okay, now let's take this number now, which is the negative version of that. Okay, and what it'll allow me to do is, because I've got the negative version, if I perform addition, that is the equivalent of subtracting. So 0 plus, now I can perform addition. 0 plus 1 is 1. 0 plus 1 is 1. 1 plus 0 or 0 plus 1 is 1. 1 plus 1 is 2. Okay, now what you will notice is that I've actually ended up with a number larger than what I started with, okay? Because I'm performing this addition, what I actually have to do is lose the carry bit. So if I start with 4 bits and I end up with 5, I actually have to get rid of this bit here to the left. So if I end up with more bits than I started, so if I end up with 9 bits and I only started with an 8-bit number, or if I end up with 5 bits like I did and I only had a 4-bit number to start with, I just get rid of the carry bit on the left. So the answer for this question, 1, 1, 1, 0 minus 0, 1, 1, 1 is 0, 1, 1, 1. Okay, that's it, guys. Okay, let's have a look at another example. I'm just going to erase this really quickly because I don't want to get rid of my numbers over here on the left. Okay, let's have a look at another example. So use 2's complement to perform the following arithmetic. This time I have the numbers in decimal. So I've got some extra steps. I have to make sure I convert it into binary to start with. Okay, so let's go. 9 plus negative 2. Okay, all right. So first off, I have to work out what 9 is in binary and what 2 is in binary. I'll just use 4-bit because it's easier. 1, oops, I'm in the wrong drawer. 1, 2, 4, 8. I don't need any more than 4 bits because they're only small numbers. Oakley dokley. So 9 is going to be 1, 0, 0, 1. So 1, 0, 0, 1. And 2 is going to be, ooh, that was a bit dodgy. And 2 is going to be 0, 0, 1, 0. 0, this 2 is going to be 0, 0, 1, 0. Okay, so I know I need to use 2's complement again here, guys. So I take the 2, the 9 stays the same, I take the 2, I invert it, so 1, 1, 0, 1, okay, and I add, that's its 1's complement. To get the 2's complement, I add 1, okay, 1 plus 1 is 2, 2 is 0, 1, carry the 1, 1 plus 0 is 1, 1, 1. Okay, cool. So then my number is 1, 0, 0, 1 plus 1, 1, 1, 0. Okay. So 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 2. 2 is 0, 1. Okay, as I learnt from the previous example, if I start with a 4-bit number and I end up with more bits than the numbers that I started with, I get rid of the carry bit, the final left-hand carry bit. So I've ended up with 0, 1, 1, 1. Quick way to check if I'm right. Let's just look at it realistically. 9 plus negative 2. 9 minus 2. 7. Is this 7? 1, 2, 4, 8. 4 plus 2 plus 1, 7. Sweet. Got the right number. That's a quick way to check. Okay, so that's how I do it if they're giving me a decimal number. Let's have a look here. What other examples do we have? La 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 la. Oh, I think that question actually asked. Oh no, it just says 2. I'm like, yep, that's fine. Usually, if they ask you in decimal, sorry, that was the last thing. Usually, if they ask you in decimal, so they asked, what is it? Rather than just giving them the binary 0, 1, 1, 1, actually have another line underneath that equals 7. So just show how you can go back to that decimal. So using 8-bit 2's complement, solve the following equation using addition, show out the working in binary, and give the decimal value of the 2 values shown and the results obtained. Okay, so this is a hard one. This is 2011 trials. This is a hard one. Or explain how 2's complement is used in the binary subtraction. Okay, let's start with the 2011 trials one first. Actually, no, I'm going to skip that. You guys can do that question as an example. I'm going to do this because it has an explain on it, and I want to show you how I would give an explanation. Okay, so this is my number. Okay, cool. So I'm just going to do this nice and quick, so hopefully you guys are getting the hang of it. This is the number here that I care about, finding the 2's complement of. So let's invert it and find its ones. 1, 0, 1, 1, 0, 1, 0, 1, and add 1 to find 2's. 1 plus 1 is 2, carry the 1, beautiful, got a 0, that's what I like. 1, 1, 0, 1, 1, 0, 1. Okie dokie, so actually the number I'm after here is 1, 0, 1, 1, 0, 1, 1, 0. That is my, and I'll just make it a yellow color so I know. That's my, oh, actually yellow is horrific to be able to see. Oh, why can't I, oh, can't get it again. Oh, that's annoying. Can I select it? Yeah, oh, I can. There we go. Let's make it orange or something so I know. Okay, so that's its 2's. Okay, so let's draw this down here, everyone. 0, 0, 0, 1, 1, 0, 0, 1, 1, plus 1, 0, 1, 1, 0, 1, 1, 0. Whooshka. 1 plus 0 is 1. Ooh, Nick close. 1 plus 1 is 2. 0, carry the 1. Remember, 2. 1 plus 1 is 2. 1 plus 0 plus 1 is 2. 0, carry the 1. 1 plus 0 plus 0 is 1. 1 plus 1 is 2. Carry the 0. First time I've had this circumstance. 1 plus 1 plus 1 is 3. 1, carry 2 ones. Oh, sorry. Yeah, no. 3, 1, carry the 1, my bad. That's 4. 4 is the hard one. 1 plus 0 is 1. 0 plus 1 is 1. Beautiful. Okay. That's my answer there. Okay. So quick way that I can check to see if I'm right is I can actually convert. So it actually asked you for what the original numbers were. So, oh God, if I work that out, that's going to take me a century. Oh no, was this the explain? Yeah, explain how 2's bit complement is used in the binary subtraction. Sorry, I did do this one. Okay, cool. This is my explanation for 4 marks. As the ALU can only add manipulation, make sure you say it like this, of the subtraction arithmetic. Sorry, my T key doesn't work. It's incredibly annoying. Arithmetic has to occur. Essentially, the addition of a negative number is the same as subtraction. Hence, you find the ones whoops, I've lost this. You find the ones complement by inverting the second number the 2's complement by adding 1 to the 1's complement and then adding the 2's complement, i.e. the negative equivalent of the number to the first binary number. In this way, you are performing subtraction. Ta-da! There's your explanation.